Chapter 1, Section 1 is about basic operations with whole numbers and decimals. So we're first going to go over our system of numbers. Our system of numbers uses the decimal number system, which uses 10 symbols that are called your digits. So those would be the numbers 0 through 9. Place value represents the placement of the number in the system, so whether it be a whole number or even when we get into our decimals. So we're going to first go into the different types of numbers. So natural numbers, which are also known as our counting numbers, start at 1 and go up from there. And those would go on infinitely. Whole numbers are the same as natural numbers, except it starts at 0 and then goes up. So the whole number place values are arranged in periods, and those are groups of 3. So when you think about like writing a really big number, you would start at the end and you would count in 3 to create a comma, and you keep doing that until you get towards no more groups of 3. So commas are used to separate these periods, and I'm going to go in now to the different periods and the different names that we have for them. So the first period of 3, those are just called units. The second period of 3 is called thousands. After that, we go into millions, then billions, and then trillions. Now, there are more periods after that, but these are the ones that you'd probably most often see. It's a rare case that you're going to be using a number that's even bigger than a trillion. So the first thing we can do is talk about comparing numbers, and those numbers can be arranged on a number line. So remember, number lines go on forever in both directions. 0 would be in the middle, and then you would have numbers like 1, 2, and 3 to the right, -1, -2, -3 to the left. Now the number or the symbol infinity is like a sideways 8, and that represents that all numbers continue indefinitely without end. So they go on forever and ever and ever in both directions. An inequality is a way that you can actually compare numbers based off their placement on the number line. So less than symbol looks like that, it opens up to the right. Greater than switches it, it opens up to the left. So the first thing we're going to do is write a comparison with the numbers 12 and 19. And there's actually 2 different ways that you could do that. You could have 12 be less than 19, or you could flip it around and say that 19 is greater than 12. So both of those would be acceptable for comparing them for inequalities. And there's 2 separate ones that you could do there. Okay, getting into fractions and decimals next. So fraction is a way of writing numbers that are parts of a whole number, and the denominator, which would be the bottom number, represents the number of parts that a whole unit contains. The numerator, which is on top, represents the number of parts that are being considered. So denominator would be like the entire piece of pizza, while the numerator would be the number of slices that you ate. A decimal is the fraction represented as like a whole number, but it's easiest when we think about decimals, and especially denominators, if it's 10 or if it's some power of 10, such as 100 or 1,000. You can also have mixed numbers, which is when you have both a whole number part and a fraction part. So when you're trying to write a fraction as a decimal, what you want to do, especially if it's over something that's like a power of 10, these are easiest to do. You can use the denominator to find the number of decimal places. So since 1,000 has 3 zeros, there's going to be 3 decimal places that are going to be needed. You put 17, that number that's on the top in the numerator, all the way over to the right as far as you can, and then you put in a 0 in for any missing blanks that you haven't been able to fill in yet. You also have probably learned at some point that you take 17, the decimal place is sitting here, and you move it to the left 1, 2, 3 times. So it moves the decimal place to here, and you fill this in with a 0. So you still get that 0.017. So let's look at this example where we're going to write these different numbers as decimal numbers. So 3 over 10 would be the same thing as 0.3. 25 over 100 would be the same thing as 0.25. 425 over 1,000 would be the same thing as 0.425. And 3 over 1,000 would be the same thing as 0.003. When you're trying to compare decimals, looking at the numbers, go until the numbers are no longer the same. So I have a 3, 2, and a 4 for both of these sets of numbers here. So the numbers that I'm really going to be comparing are the 7 and this 8. So what I'm going to do then is look at which number is bigger or smaller, depending on how I want to write my inequality here. But if I keep them in order, 32.47 and 32.48, 8 is bigger than 7, which means that 32.48 is the bigger number. We can do the same thing with this next one where we're trying to arrange these numbers from smallest to largest. So the smallest is going to be 4. The middle number is going to be that 4.05. And the biggest number is going to be 4.1. Rounding numbers is when you're trying to find the closest approximate number to the number that you're given. So a lot of times these problems will specify how they want you to round. Do they want you to round to hundreds, thousands? But we even have problems where you'll have to round decimals. So you'll have to round to the nearest tenths, hundredths, something like that. For this first example, it says that Oregon has a land area of 96,187 miles. What would be a reasonable approximate number for this land area? So depending on how they wanted you to round this one, if we think about 96,187, if I first wanted to round it to tens, I would be looking at my 87. Remember, rounding rules say that if the number is 5 or greater, you round up. If it's 5 or if it's 4 or less, you round down. So I'm going to round this to 96,190. Now let's say they want us to round to hundreds, so I look at 190. So ask yourself, is 190 closer to 200 or 100? Hopefully you said 200, so we round up to 96,200. Now if I'm wanting to round up to like the nearest 1,000, again I look at this 200 and that's 6,200 and I think, is that closer to 7,000 or 6,000? So I would round this to 96,000. Now if they wanted me to keep going, so if they wanted it to the nearest 100,000 or 10,000, 96,000 is really close to 100,000. So I just showed you a couple different ways we could round that number, and since they didn't specify, as long as you probably gave me one of these down here, that would be acceptable. But if they specify where they want you to round it, then you should follow kind of the steps that I took to get there. Now, rounding with decimals, if we want to go to the hundredths place, hundredth is 2 decimals out. So you look at that 0.897. So 97, the 7 is going to make this round up to 10. But since it's already a 0 here, you still have to kind of figure that 1 into the 8. So this is really going to be 46.90. And that's still written in technical hundredths terms. Now rounding something to the nearest dollar, look at the cents. If it's less than 50 cents, you want to round down. If it's greater than 50 cents, you want to round up. So this would be $293. When it comes to adding and subtracting whole numbers and decimals, we have a couple properties that we want to talk about. First, the commutative property of addition says that 2 numbers can be added in any order and the sum will remain the same. So that means if I have 2 quantities like A and B and I'm adding them together, it doesn't matter if I do A plus B or if I do B plus A. I'm going to get the same answer. The associative property of addition is talking about grouping. So a lot of times you'll see parentheses in these kind of problems. So I could have A plus B plus C get grouped together. And that would be the same thing if I grouped A and B together instead and then added C. The zero property of addition, or is also known as the additive identity, is when you add 0 to any number, it's going to result in the same number. So if I take A plus 0, I'm still going to be left with A. Now for these next couple of problems when it comes to adding and subtracting, they want you to try to start doing some of these things without a calculator, just so that you're not always relying on that. So when I'm trying to add up a bunch of numbers like this problem is talking about shipping fees, start with the biggest number and then stack them on top of each other. So we have 250, 75, 12, and then 8. Then we put a plus sign, and then you add the appropriate columns. So 5 plus 2 plus 8 is going to be 15, carry the 1. And then you have 1 plus 5 plus 7 plus 1. So you're going to have 6, 7, 14, carry the 1. 2 plus 1 is going to be 3. So 345, and this would be pounds. Make sure if your question has a label involved that your answer has a label. Now the same thing happens with decimals. So I'm going to put my 42.3, 17 right underneath it, and then I also have 0.36. So for 17 there is no decimal point, so I'm going to add 1. I'm also going to add in 2 zeros, and I'm going to add in a 0 at the end of that 42.3, and that's just to help me keep everything in line. Now I can also add a 0 in front of the 0 on that 0.36. That way everything has the same number of digits in the problem. Then we add like we did before. So 006 would be 6, 303 would be 6, bring down the decimal point, 2 and 7 would be 9, 4 and 1 would be 5. So 59.66. Estimate is another word for rounding, and it's often referred to when we're using a non-zero digit. A non-zero digit is going to be something like 1, 2, 3, all the way up to 9. So really anything from our natural numbers that we talked about earlier that's not 0. For example, if we're talking about this home renovators company and they're trying to estimate how much it's going to cost for a job, we would want to round these answers, it says, to the thousands and then find the exact amount and check it. So for my 3 numbers here, these are the ones that I want to round to the thousands. So we've got 16,000, 24,000, and then 6,000. So we're going to add these together, and this is going to be an estimate of $46,000. Now, if you actually add them, and I would say you could probably grab a calculator to help you do that, the exact answer is going to come out to be $46,284.45.